Cool. Hello, everybody. We are at the beginning of week 11. This week is going to be kind of short, actually. It's probably going to be like 1 hour for today, and then next on Thursday, probably another hour. These are pretty short topics, but pretty important actually. This week, today we'll learn about for loops. This is kind of like a way of repeating code in a finite amount of steps. And then on Thursday, we'll cover while loops. This is a way of repeating code that can possibly be infinite. So yeah, today is finite things, and then Thursday is possibly infinite things. Okay. I do want to stress that next week will be pretty dense, actually. Next week is week 12. We're going to be covering looping algorithms. This is going to rely on full understanding of the basic syntax that we'll cover today. So even though today might seem kind of easy, it's actually going to pick up a lot on week 12. So here, let's get started talking about loops. So far, our programs have been still kind of flat, meaning that we haven't really repeated code yet. So we'll talk about looping. We'll talk about loops today. Finite loops, for loops. Okay, there's lesson 15. So let me open that up. Okay, lesson 15. Once again, it's going to be a really short lesson. It's probably going to be like less than an hour. But I'm relying on everyone to kind of play around with it and fully understand these things. Okay, cool. The for loop. A for loop is a way of repeating code. In particular, it lets us repeat code on elements inside of some sort of sequence. What is a sequence, though? The first type of sequence we've seen in this class was all the way back in week 2 when we talked about lists. A list is a sequence. So if I were to declare a list of here, I'm going to hard code a list of animals. I'm just going to hard code a list of 3 strings. So lions, tigers, and bears. Right, this is just a hard coded list. Sometimes it is necessary to go through a list and perform the same operation on each element. In this notebook, the only operation we're going to see is really just accessing or printing. So yeah, we're just going to be doing some reading today, reading from sequences. In particular, if we wanted to print out every element in this list, we could access things individually one at a time. So that's what the for loop here. A for loop lets you repeat code where the syntax goes for something. Right, so you could put anything here. Like you could literally put for something in animals. You can print that something. So this is a for loop that's going to go through this whole sequence and kind of just print it out one at a time, line by line. The reason this works is this highlighted part right here, something in animals. When we're writing a for loop, this right here on the right, the animals, this must be some sort of sequence. Right? In this case, this sequence is a list. And then this something right here, this is just a name of a variable. It could literally be anything. Right? You can name it foo, meaning that we'll have to print foo, and it's going to give us the same exact thing. Basically, foo is representing each individual element. All right, people cool with this so far? So yeah, all we're doing is iterating through it. The indents do matter here. So this is 4 spaces or a tab. The indents matter because if I were to print like some equal signs here and try to separate each line, you see how each of them we're printing a bunch of equal signs for each of them. The indents matter because if this wasn't indented, this technically belongs outside of the loop. meaning that it's only going to happen once. So I just unindented it, meaning it's now going to print it once right here. So yeah, hopefully people are cool with this. Typically, it's good to name the variable something descriptive. Like foo is not really a descriptive name. We got to think of a variable name that represents each thing in this list. So a good variable name would probably be animal, without the s, right? Just animal, single, no s. So that's probably a good variable name. Okay, people getting a sense of what today's stuff is. This is a for loop. It's good for iterating through a finite sequence. Okay, let's go through here. So yeah, this is what the skeleton, the anatomy of a for loop looks like. Basically, for something in a statement, we can access it and do something with it. In this notebook, the only thing we're really going to do is print. Okay, let's talk about some more sequences. We just went through a list. Here's a table of some sequences that we've seen. We've seen a list right here. It's a sequence of things. We've seen a string. A string is a sequence of characters, like letters. For example, down here, if we were to have a sentence equal to this string is a sequence of characters, and we can iterate through it. So let me do an example down here. Let me just do an example of iterating through a string. So let's just say I create some random string, like text is equal to hello world. So this is a string. If we were to put this into a for loop, like for something in text, we could go ahead and access it. In this case, this something represents the variable name that refers to every single letter here. So if we were to print it, we should end up with a line by line letters. So there it is. I just ran it, and we see it says hello world, line by line. Are people cool with this so far? So yeah, in this case, the sequence is this string. A better variable name for this something would probably be like letter or character, right? It's probably character is a good name for character in text. Print character. This could be anything though, but yeah, something descriptive, right? Code should usually be readable, so this is pretty readable. People cool with this so far? So we just did an example of iterating through a list up here, and we did an example of iterating through a string. Okay, let's talk about some more sequences. So going through a table here, a file handle is also a sequence. This is stuff that we saw last week. You might recall in last week when we talked about file input and output. I meant 2 weeks ago. 2 weeks ago, we talked about file input and output. And you might remember that there was a place here where you can convert a file handle into a list. Basically, if you were to convert a file handle into a list, it would pretty much be each sequence represents each line. So, for example, if I were to iterate through this file here, there's a file called example.txt. It's inside of the files directory over here. So files directory. There's a example.txt here that contains 5 lines. It's possible to store each of these lines into a list. And the way we do that is by converting the file handle into a list. So once again, this is stuff from lesson 13. I'm referring to this section right here, reading lines into a list. So let's go ahead and apply this. We're gonna open up this file here. So let me make a new text cell here, code cell. Make a new code cell. This is going to be iterating through a file handle. Okay, so first thing, we're gonna go ahead and open up this file, example.txt. I'm gonna open it up in read mode. So this returns a file handle. So I'm gonna store it in a variable called file handle. And a good programming practice is to always close it. Otherwise you have something called memory leaks. So I'm gonna close it. And then in between, I'm going to go ahead and convert that file handle into a list. So I'm going to convert it into a list, meaning that all we have to do is say file handle and then wrap it in this list constructor. Oh, I haven't even talked about constructors yet. But yeah, this is just a conversion. We're converting a file handle into a list, and we can store it. I'm going to store it into a variable called lines. Lines will become a list. So check this out. I'm going to go ahead and print the lines real quick just to verify what happened here. So I'll press play. And okay, I got an error message here. So let's see. It looks like I failed on this very first line. The file handle is equal to open. Let's see what the error message is. It says no such file. No such file. So it's saying that example.txt doesn't exist. It does exist. I just got the path wrong. In this case, the path is relative to the lesson notebook. The lesson notebook is located over here, right here. So if we want to go inside of and get this text file, we would have to make the path relative, meaning that we would have to go inside of files and then example. So I need to modify this path to files/example. This is gonna give us the correct one. So let's press play here. And okay, cool. So it looks like it opened it, and I converted the file handle to a list, and then go ahead and printed the list. So here's the list. The list has 5 items separated by commas. It's really just a list of 5 strings. That's really what it is. So lines is a list. This is something we can iterate. We can go ahead and iterate the list by saying for line in lines, print line. So let's do that, and people will kind of see what's happening here. Lines is a list. So this variable named line is a single element in that list. And yeah, we're just printing it out. Okay, people cool with this so far? So that's kind of an example of going through the sequence of lines. Okay, it looks like I didn't really have to convert it to a file handle. I think this was unnecessary here. You can probably get away with not converting it. So I'm going to go ahead and comment this out. And instead of iterating through a list, you can just iterate through a file handle. And then once again, make sure to close it at the end. Okay, so this should give us the same behavior. Yeah, exactly. Yeah, same behavior. This is probably a little more efficient, though. It's probably more space efficient because the earlier solution required us to convert it to a list right here. Here's our. Let me redo. Our earlier solution was converting the file handle into a list, which can take up a lot of space. If our file handle was really large, like if we had millions of lines, then our list would end up being 1,000,000 elements. So this is a little space inefficient. It's probably better to iterate through the file handle. So here it is. Okay, people cool with this so far? Okay, cool. Yeah, good old for loops. We're repeating things on sequences. Okay, we just talked about 3 different types of sequences. We talked about strings, we talked about file handles, and lists. One more sequence. This is a dictionary. Dictionaries are also sequences of things. In this case, if we were to iterate through a dictionary, it would give us the keys. So let me go ahead and hard code a dictionary and iterate through it. I'm just gonna copy this one over here. So this is stuff from week 2. Let me copy this. Do an example of iterating through a dictionary. Okay, so say I hard coded a dictionary called animals. Let me clean this up a bit. Okay, if you're wondering where this came from, this is from a long time ago. If you take a look at the dictionaries lesson from 2 months ago, damn, it's been that long? 2 months? Yeah, that's crazy. I don't know, it was 2 months ago. So yeah, we're pretty much representing this dictionary here, right? A dictionary is a sequence that maps a key to a value. If we were to go ahead and iterate through it, let's see what happens. So I'm going to say for something in animals. Animals is a sequence. Let's see what this something is. So I'll go ahead and print that something. Press play, and we see that this something represents every key in the dictionary. So yeah, if you were to iterate through a dictionary, it really just goes through all the keys. Very important, it doesn't go through all the values. A good name for this variable would probably be like a key. All right, for key in animals, print key. So we could say lion there. If you were to access the value, how would you do that? There's actually multiple ways on printing the value here. One way we could get the value is by indexing the key. Like if you were to, you might remember that you can get the value by saying something like animals and then key. Remember in dictionaries, putting the key in here will return this. So if we said animals lion, this would give us Panthera leo. If we said animals tiger, this would give us the scientific name here, and so on. So this is going to print out the values. I just press play. Okay, and it might be a little more descriptive if I made this a little nicer print statement. Let me turn this into an F string to make it a little easier to read. I'll say print out the key and the value. So the key, I'll interpolate it here, and then put a colon here. So it's going to print out the key and value. Right, the key is lying here, and then the value is right over here. All right, people cool with this so far? Okay. If you wanted to make this a little easier to read, you could make a variable. You could make this, you could say value is equal to animal's key, and then go ahead and print that. This is a little easier to read. Does the same exact thing. Okay. People cool with this so far? All right. Sounds good. Sounds good. Cool. So we just went through a few different for loops. In particular, we went through for loops that goes through all these different sequences. These are finite sequences, meaning that you're guaranteed that the loop will end. The reason why is because these are all finite sequences. Okay. Any questions about this so far? Some good old for loops. Okay, let me check the lab real quick. I'm gonna see if we have enough to do the lab. Okay, let me just skim this. Go through a list. Do a counting loop. Oh, okay, no, we don't have enough to do this yet. All right, let's go back to the lesson. Okay, this is finally, the last piece of the notebook, we're going to iterate through numbers. Sometimes it's necessary to represent a certain amount of iterations. Iterations mean how many times to do the loop. You know, in these cases up here, the number of iterations is defined by the length of the sequence. So here, let me back up a bit. So over here in the very beginning, how many times does this happen? It happens 3 times because the length of animals is 3. You know what I mean? Just if we were to print the length of the list, length of the sequence, there's a length function which tells us the size of the thing. A length of sequence is 3. So this for loop is guaranteed to happen only 3 times. And then down here, the length of the sequence right here, length of sequence is length of text as an F string. Length of sequence is 12, meaning we're guaranteed to iterate 12 times. So yeah, that's kind of what I mean by finite. In this case, it's possible to define certain ranges where maybe you want more control on how many times to do something. So in this case, let's introduce a type of object called a range. This is native to Python. Python has a function called range. I'll pull it up real quick. You can Google up Python functions and then click on the primary documentation here. The built-in functions, the native ones, one of it is the range. So the range is right here. I'm gonna go ahead and click it. Here it is. It's a class. I know people might not know what classes are yet. In a couple of weeks, we'll talk about classes. So it'll come together in a bit. But a class is pretty much like a fancy variable type. That's pretty much what it is. And in this case, the range allows us to specify kind of like a list of numbers. That's really what it is. For example, if I were to say range 10, this in Python evaluates to an object. An object is like a fancy variable. This object can be converted to a list. If we were to convert it to a list, we'll see that it's kind of like a sequence of numbers. Range 10 represents a sequence from 0 all the way to 9, and not including 10. So yeah, there's 10 numbers here in total. And you know, just to kind of change it up a bit, right? Range 10, if I go to 11, this is going to give us a 0 all the way to 10, and so on. So by using this range object, we can define our own iterations. We can define how many times the for loop will happen. Meaning, we can just go ahead and iterate through this. Like let's say range 10. Right, range 10. This is a sequence that goes from 0 all the way to 9. So if we were to access each element, it's literally just going to print, 0 all the way to 9. Are people cool with this so far? Okay. This range function has a lot of power, by the way. In this case, we only used one argument, one parameter. But there are also optional parameters too. Sometimes you might want to represent numbers in different ranges. Like maybe let's say you wanted to represent 5 to 10 instead of 0 to 9. In that case, we could take advantage of these additional arguments that represent the lower bound and the upper bound. So we could go ahead and implement that, right? Instead of saying 10, we could say 5 to 10. and this is going to give us a sequence from 5 to 9. People see what I mean? The reason why is because range 5 to 10 is an object that represents 5 to 10, but if we convert that object to a list, we get the sequence here. All right, people cool with this? This is actually a pretty useful loop, by the way. It might not seem like it. A use case for this is to maybe simulate years. Like let's say we wanted to simulate the year 2025 all the way to maybe 2050. Right? Maybe for some reason you wanted to print out all of those. So in this case, you know, we're representing 2025 all the way to 2049. This is really useful stuff. Like maybe say you're simulating some sort of interest rate, or maybe here let's keep it simple. Let's maybe say we're simulating a bank account getting bigger and bigger. So for example, you know, say you had a savings account. I'm gonna hard code a number here. Let's say we started off with 2,000 in our savings account, and maybe we wanted to simulate our savings account getting bigger and bigger. Maybe we could use like a simple interest. People know what I mean by simple interest or compound interest. Compound interest. Let me just pull this up. I'll pull up a picture. Compound interest is, let's see, I don't really want to pull up the closed form solution. Yeah, you know, I'm not going to use these over here. This is actually called a closed form solution, meaning that it won't use a loop. Here, let me go back to the notebook. Say we were to have 2,000 in our savings account, and every year it grows. For people who have a savings account, there's something called an interest rate, and that interest rate defines how much money you get for a certain time. So for this case, I'm gonna simulate a interest. I'm gonna simulate compound interest, meaning that our savings account should get bigger and bigger. So here, let's take this step by step. For each of these years, let's just go ahead and print out how much money we have. So here, in the print statement, I'm gonna say in the year number, you have this much money. So you have this much money. I'm gonna put savings account here, and then this number is meant to be a variable, so I'm gonna put this in a curly braces. So let me go ahead and play this, and people see what I mean. So I'll play this. Let me make this a little neater. I'll put a $sign here. So there you go. Just put a $sign, and it says in 2025 you have 2,000 bucks, and same for all the other years. We're not really compounding the interest yet. I just remembered. I just thought of this thing real quick. It's probably a better variable name to name this year instead of number, because yeah, it's just a little more readable. So I'm gonna change this variable name. In the year you have this much money. So let's go ahead and simulate compound interest, and to make things a little easier, we're just gonna simulate interest rates per year. Okay, so every year the account will grow by a specified rate. Right, account will grow by specified rate. In this case, I'm just gonna make up a random number. Like let's just say our interest rate is equal to 0.05. This is saying that our interest rate is 5%. Here, let me pull up a more accurate one actually. Let me look up what the interest rate is for Discover. people here might have a Discover account. So let me look at this Discover interest rates for the savings account. Discover. Okay, cool. Cool. Let's see what they're. Oh, damn, it got lower. So the Discover interest rate is 3.4, meaning that it's really defining how much money you get after a certain amount of time. So that's crazy. This number used to be 5%. It got a lot lower. Interesting. So let's pretend that we're simulating a savings account getting bigger by like 3.4%. So let me go ahead and change this variable here. 5% is pretty high. So 0.35, is that it? 0.34. Okay. And once again, to keep things simple, we're just going to accumulate the savings account for every year. Meaning that every year we're going to accumulate some sort of interest. Right? Every year we need to calculate how much we accumulated. So we can represent that by saying it's your savings account times interest rate. This number gives you how much you accumulated. So I'll name it accumulated interest is equal to. This is a good variable name because every year we're going to multiply the savings account by the interest rate. This gives us our accumulated interest. And now all we need to do is add this interest back into our savings account. So I'm going to say savings account is equal to savings account plus the accumulated interest. All right, people see what's happening here. So every year we accumulate that interest. So we're going to add it to our previous savings account. That's what's happening. So let me go ahead and press play here. And you see what's happening here? You know, in the year 2025, we will end up with $2,068, which makes sense, right? Because we started off with $2,000, and with an interest rate of 0.34. Here, let me pull up a calculator so you see what I'm talking about. Here's a calculator. So we start off with 2,000. If we were to accumulate 3.4%, we get 68. All right, $68 is our accumulated interest. So we add on the $68. So we end up with 2,068. And then the next year comes, our bank account gets bigger. Our savings account is 2068. It gets bigger, so we multiply this by 0.034, I mean. So that year we accumulated 70.312. So this is the accumulated interest, meaning that we would add it to our previous savings account. So add it to the previous savings account, which is 2068. This gives us 2138, and that's giving us this next number here. Yeah, people see what's happening. All right, we're simulating a bank account getting bigger and bigger. So let me clean this up a bit. If anything, with money, people really only care about 2 decimal places. So I'm gonna go ahead and round this output. This savings account variable should be rounded, probably to 2 decimal places. So I'll round it to 2 decimal places. Press play again. And, there we go. It rounded it. Okay, cool. Some cases it didn't round. I think I need to round in a different way. But anyways, yeah, people get the point on what this for loop is doing, right? Yeah, some pretty cool stuff. Earlier I attempted to bring up a formula. This formula over here, the compound interest, this is a closed form solution, meaning that you don't need to loop it to calculate it. If you're curious, this compound interest formula is actually derived from finding the limit of something. So I'm kind of going on to a tangent here, but if you were to look at the derivation of compound interest, like how is that formula made? This formula is pretty much made by simulating a loop and then defining the equation in the end. So if you're curious, let's see. Let me look at the compound interest derivation. Let me see. Let me look up something. I'll look up limit. It involves taking the limit of something. Continuous. This one. Yeah, no, never mind. I'm not gonna go through this rabbit hole, but I was pretty much gonna show a bit of calculus, where the calculus is really taking the limit of this equation right here. If you were to take the limit of this equation as it reaches infinity, you get a closed form solution. Okay. Here, let's carry on with for loops. So we were talking about numerical sequences, which allows you to define your own range, or maybe define your own amount of iterations. And we use this range object in Python. This range object has a lot of power. Okay. Great. Let's go ahead and oh, this is the end of the notebook. Cool. So yeah, pop quiz. What's the difference between all of these? What's the difference? There's no difference. It's really just the variable names. Like if I were to hard code animals here, right? Animals. I'm gonna hard code a list of strings. Probably duck, chicken, beef, or no, animals, cow. Let's see. So here's a sequence of 3 items. If we were to iterate through it, right, for something in animals, print something. Right, we've seen this in the very beginning. This is printing every element here. All right, so all of these loops do the same thing. These are just kind of readability things. Which of these loops is more readable? Probably this second one. This is arguably more readable because the variable represents every item in here. So animal and then animals, right? Singular and plural. So it's probably better to name it animal here. Okay, people cool with this so far? Okay, there's so many different ways you can do this, by the way. Another way you can represent this for loop, and if you were to do a different language, you could represent this with a range. You know how earlier we talked about numerical sequences? We could use the same thing. Instead of iterating through this the sequence, we could say for something in range. In this case, the range should be 3. So the 3 means that we're going to go from 0, 1, and 2, which will allow us to access each individual element here. This something variable is probably a better variable name if we name it like index or number, right? Because range gives us once again range of 3 here. This gives us an object 0 to 3, and we convert it to a sequence, a list sequence. It represents 0, 1, 2. So that's what's happening down here, right? Number 0, 1, 2. I'll name it index or a position. You can name it position if you want. Doesn't matter. So for each position, we can go ahead and use it and index these elements here. We can just say print animals at position. Same thing. So I'll press play. And yeah, same exact thing as above. This second one is a little more general, and if you were to play around with other languages like C, C++, Java, this syntax will be supported on multiple languages. The syntax meaning we're iterating through all the indexes. Cool. If anything, this 3 is kind of hard coded. This 3 assumes that our list is 3 items, and it can possibly break if our list was like 2 items. Let's say my list was 2 items here. This means that we're going to get index out of bounds error here, because position will be 0, 1, and 2, but then that 2 doesn't exist. There's 0, 1, and then 2 is out of bounds. So if I press play here, I'm going to get a index out of bounds error, because yeah, we were able to print duck, chicken, 0, 1, but then when we got to 2, it failed here. If you wanted to kind of debug what's happening, you could do some more print statements. You could print another thing here. This is kind of like how you would debug in an intro class. The debugging means to kind of visualize what's happening in the program. So I'm going to go ahead and visualize what's happening with the position. Position is at position, and this is going to say position is at 0, we print duck. Position is at 1, we print chicken. Position is at 2, and then we get an index out of bounds error. The index out of bounds is happening right here. So yeah, this is a kind of dangerous code because we hard coded the 3. If anything, it might be necessary to generalize this number 3. This 3, it should be better represented as the length of the sequence. So now this length animals will resolve to 2, and it'll let us not get an index out of bounds error. So I'll press play here, and yeah, no more errors. The cool thing about this loop is we can generalize to different lists. We can put beef here, cow. We could put lion here, put a tiger, and the for loop will do the same thing. The length here is going to be 5, meaning that the range will go from 0 all the way to 4. Okay, people cool with that so far. So just kind of 2 different ways on doing things. Okay, great. Okay, let me take a look at the lab. We just finished the lesson. I think we have enough to do the lab. Okay. Yeah, we have enough actually. And I'll actually let folks do this on their own. I'm not actually gonna go through the solutions today. Probably on Thursday I will. It's a good idea to try this out yourself before seeing the solution. So I'm actually gonna stop here and let folks try it. So yeah, once again, today is a really short day. We're just introducing the for loop. The for loop is a way on stepping through a sequence of finite items. On Thursday, we're going to talk about while loops. It's actually the same thing, but it'll allow us to do things that are possibly infinite, because sometimes programs run infinitely, and you will need to loop things infinitely in that case. So yeah, we'll talk about infinite loops on Thursday. But yeah, if folks could try out the lab themselves, that would be great. I'm heavily relying on folks to kind of play around with loops, because once again, next week on week 12, it's going to be kind of dense. Week 12 is arguably one of the trickiest topics in this course. The reason why is because looping algorithms will kind of exercise our problem-solving skills. In particular, there's something called algorithmic thinking. Algorithmic thinking is a way of breaking down your thoughts into a series of statements known as algorithms. So that's kind of the tricky part of computer science in general, kind of just formalizing your approach. Okay, let's see. Yeah, that's about it for today. It's a really short day. That's crazy. Let me think for a minute. I feel like feel like we skipped over something. Talk about a for loop. Okay, yeah, that's it for today then. So the lab, all this lab is doing is practicing accessing elements. There's there's not a lot of computation going on here. It's just practicing if you can navigate a sequence and print out every element. That's really what all of these exercises is doing. Hey, write a loop that goes through a sequence and prints something. Yeah, that's all this really is. It's really just a looped print statement. Okay, thank you all for coming. It's gonna be a really short day. On Wednesday, Thursday, we're going to talk about while loops and then introduce this new assignment called drawing. You know what? Here, I'll actually pull up this lesson right now. After you finish the lab, you should have enough to finish this project. This is the last project that uses the turtle. Here, let me pull it up right now. It's this project is really asking if you can write a loop that can make the turtle repeat some actions. That's really what it's doing. So I'll pull up the assignment right now. Assignment. Drawing. The last turtle assignment. Okay, there it is downloaded. I'm gonna go ahead and dedicate a folder to this. Week 11 drawing. There it is. Go here. Let me quit all these tabs. Okay, here is the notebook for the turtle. Let me run this first cell. The whole point of this notebook is to implement a loop that can draw a cool shape. In this case, the shape is a spiral. So if you scroll down to the bottom of the notebook, there's kind of some examples on what you can make. But yeah, this is really saying, hey, can you write a for loop that does something? So there's some cells up here you should read later. These cells are defining a functions that we can use. For example, a triangle right here. This is something that you wrote a long time ago. You might remember this from week 5. In the week 5 robot cat, we ended up writing functions, and yeah, this was one of them. It's possible to generalize this into a for loop because a triangle consists of kind of 3 lines. So you could collapse this into a for loop, and you'll see that down here. Pretty much this is saying for loop that does something 3 times, and in this case it's just drawing and turning 3 times. That's all you need for a triangle. So that's applying the for loop here. There's actually a really cool way on generalizing of the shapes. You can actually draw different types of shapes if you were to generalize this function into something else. So here there's a provided function called shape. This is a very useful helper function that you might use in the project. It's this function pretty much lets you draw different types of shapes. For example, if we were to draw a triangle here, I just inserted another cell here. If you were to draw a triangle is represented by 3 sides. So I'm going to call the shape function and say, hey, I want 3 sides. So there we go, there's 3 sides. And then the next argument represents how big the triangle is. the size. So let's say I wanted the triangle to be like 100 pixels, meaning that each side is 100 pixels. And then finally, you don't have to worry about this too much. The last argument represents the number of turns. This is kind of a tricky argument to understand, but it kind of defines how the turtle will move when it's drawing the shape. So if I were to keep it as 1, this means only turn once for every turn, every side I mean. And this is going to give us a triangle right here. So if I were to change this first number to a 4, this would give us a square. Right, people see what's happening here because the first argument represents how many sides. If I say 5, this is going to give us a some sort of shape. I forget what this is called, like a hexagon or something. Change it to 6. This is going to give us another thing. Change to 7, gives us another shape. 8, gives us this shape. So yeah, pretty cool stuff. I would recommend studying what this function is doing. It's pretty cool stuff. Additionally, if I were to do a hexagon and change this last argument to like a 2, let's see what will happen. So I'll change the last argument to a 2. It's gonna make a star. So this is a little hard to explain why it's making a star, but basically this 2 argument is controlling how much the turtle is turning. So if you wanted to trace through it, there's this function is calculating the angle, and basically if we were to change the number of turns, then the angle would change as well. And in this case, it changed the angle where it's like a hexagon, but within every side we're turning a different amount. So yeah, this is a triangle. I mean a star right here. You can draw a lot of things with this function. Cool. Another part of this notebook is talking about rainbow colors. I don't think we've talked about colors that much, but you could look through these examples down here. This example is showing how a turtle can change color while it's moved. In this case, these first 4 lines, they're not really doing much. It's just setting up the turtle to be in the right position. So if I were to comment this out, just focus on these 4 lines. This is just initializing the turtle and making it face right. That's all it's doing. And then this for loop right here, this is the cool part here. This for loop is saying do something 12 times. Remember this range here? This range is a sequence that goes from 0 all the way to 11. So we're doing something 12 times. In particular, we're going to move the turtle 20 pixels 12 times. And then after we move it, change the color. So you'll see here there's a variable that represents the color, and within each iteration the color is increasing by 60. But basically, if you're wondering what it means to add to a color, it's really just referencing this wheel here. 60, if we start at 0, this represents red. We add 60, this brings us to yellow. Add another 60, brings us to green, and then light blue and dark blue. Right, so that's why I'm adding 60, just to go through these colors. So I'll add 60 and then press play and check it out. It's pretty cool. There we go. Right, we see a turtle, and you can see each iteration here. In the first iteration, the color was red, and the reason why it was red was because we started the color at 0. The initialization 0 represents red here. So we initialized it, we drew 20 pixels, ended up being red, and then we changed the color by adding 60 to it. So when we add 60 to it, it's getting the next iteration ready for a different color. By adding 60 to it, it's saying, hey, go from 0 to 60. So then now we are at yellow, and that prints, it shows a yellow one. So then we'll move it, and then it draws it in yellow, and then we'll go ahead and change it again. And add 60, this becomes green, and so on. All right, so people seeing what's happening here. We're going through the color wheel twice. Let me actually hide the turtle so you can see the last color. I actually don't know how to hide the turtle. Let me ask. Let me look at the documentation. Help on the turtle. Let me look at the doc string to see. Okay, so there is a class function called hide turtle. I'm gonna go ahead and use that. tu.hide turtle. This will let us see the very last part. Okay, there we go. We're hiding the turtle. And yeah, it goes through the color wheel twice. And that makes sense because we're adding by 60 and we're going through a range 12. This means that we go 0, 60, 120, 180. Right, we do that. That happens 6 times, and we do it another time. Right, we do another 6 times, so we go around the wheel again. So that gives us 12 times. So yeah, hopefully people see what's happening here. So if the whole point of this project is really just to print a spiral. So yeah, go ahead and give this a shot. It's pretty cool stuff actually. There's multiple ways you can do this. But the easiest way to think about it is first see if you can at least draw a spiral. Right? Don't worry about these shapes. Just see if you can draw a plane spiral. And then if you can do the plane spiral, then you can go ahead and do shapes in between. So yeah, go ahead and give that a shot. Yeah, you should have enough to do this. All right, that's it for today, folks. Once again, today we really just talked about for loops. I'm heavily relying on folks to try this out themselves before we talk about looping algorithms. Okay, have a great day, folks. See you all on Thursday. Bye-bye.